Welcome to the lecture on embedded systems. In the previous lecture, we discussed about the FPGA, CPLD, and we discussed about the organization of FPGA. We also compared it with the CPLD, and we saw that CPLDs are faster than FPGA, but CPLDs are outdated, and mostly FPGAs are widely used as a code. Okay, instead of that. So in this lecture, I'm going to discuss about the memory of a processor or controller. Now, every embedded system has a processor or controller chip inside it, and the memory of the processor or controller is a very important part of it. Okay. So generally, if memory is present inside the processor or controller, we call it as a on-chip memory. And if the present memory is not present inside the processor or controller, we have to connect the external memory to the controller or processor. In that case, it is called as a off-chip memory. Okay. So first we will see what are the types of ROM. Then we will see what are the types of RAM. Then we will see SRAM cell implementation, DRAM cell implementation, and NVRAM. Okay. Now see, first of all, I would like to tell you that ROM, random read-only memory, is a non-volatile memory. Means that suppose you store the content and generally the ROM is used to store the control algorithm or a code or a program, okay, of the processor or controller. Okay, so once you store the data in the ROM and then you switch off the power, the contents are retained. When you switch on the power, it retains its content. The contents are not lost. So it is a non-volatile memory. Okay. So first we will see what are the different types of ROM. Let's get started with it. Types of ROM. First is the masked ROM, MROM. Okay. Now what do you mean by masked ROM? Masked ROM are one-time programmable devices. They are programmed by manufacturers. Okay. And generally they are programmed by metallization or a masking process. They consist of enhancement or depletion type of transistors, and generally those transistors are operated in the high threshold mode because the operating voltage of a high threshold mode is when the transistors are operated in the high threshold mode, their operating voltage becomes greater than ROM IC operating voltage. ROM IC consists of transistors. Every IC has a particular range of operating voltage, and the transistors which are present in that IC has the operating voltage requires operating voltage which is higher than the ROM IC operating voltage. So they are generally stored at the logic 0 state. And one more disadvantage of this masked ROM is that they are not they cannot be updated against the firmware upgrades. Means firmware of your masked ROM cannot be updated against the firmware upgrades. Okay, now whenever you're using any software, the software gets updated, and you have more features in the updated software than the previous version. So similarly, you cannot update the firmware in MROM, masked ROM. Okay, fine. Now we will move towards ROM. ROM or OTP, or is a programmable read-only memory. Now, unlike masked ROM, ROM are not pre-programmed by manufacturer. End user are responsible for programming the PROM. Okay, and they consist of the network of a polysilicon or nichrome wires. The structure of PROM is consisting of the polysilicon or nichrome wires arranged in the format of matrix. They can be also viewed as a fuses. Okay, whenever you want to store a particular pattern, programming pattern of ones and zeros in the PROM, the fuses which are blown or burned represents logic 0, and fuses which are not blown or burned represents logic 1. By default state is logic 1. Okay, so we have programmable read-only memory, which is pre-programmed by the end user. User can program it. Okay, but since whenever when we are going to design any system, its code is subjected to a lot of I mean to say that there's a possibility that the code may change. There are modifications in the code, and there are firmware upgrades. So it is not economical. So sometimes it becomes essential to reprogram the chip. We have to reprogram the chip. Suppose there is some error in the code, or it needs to get modified, or software needs to get updated. We need to do reprogramming, right? So in that case, it is not economical to use this PROM or OTP. Okay, so we are using EEPROM, erasable programmable read-only memory. Now, what is a erasable programmable read-only memory? EEPROM. Now, this EEPROM is programmed. It can be reprogrammed. It has the features of reprogramming. But how do we reprogram the EEPROM? Now, it consists of the chip, consists of the quartz crystal window, and before reprogramming, it is very important that we erase its previous data. So the chip is removed out of the board. Okay, and after that it is placed in a UV eraser device for 20 to 30 minutes, and it is exposed to ultraviolet light via quartz crystal window. Okay, so when you are exposing the device to ultraviolet rays for 20 to 30 minutes, it automatically gets erased. Previous contents gets erased, and you can reprogram the chip. But the disadvantage, it takes longer time, 20 to 30 minutes. So there is a further advancement, that is electrically erasable programmable read-only memory. What do you mean by electrically erasable programmable read-only memory? The contents of the memory are alterable by electrical signals. Electrical signals are used to alter the contents of the memory. I mean to say, now suppose you want to remove the contents, so you have to put the chip in the erase mode. When the chip is in the erase mode, automatically electrical signals alter the contents, and the previous program is erased, and you can reprogram the chip. So next is the flash memory. Now this EEPROM, the previous memory, electrically erasable, its capacity is very less. Okay, whereas a flash memory, it is the most popular memory. It has the features of EEPROM. It is a variation in the EEPROM. Same procedure is used to erase the flash memory before reprogramming. It is very important that we erase it. Okay, same as a EEPROM. It's a variation in EEPROM. The only difference is the capacity of a flash is more than the capacity of a EEPROM. Okay, and there are sectors of pages. Memory is divided into sectors or pages, and before reprogramming, it is very important that each sector or each page should be I mean to say cleared. Okay, then after clearing each sector by sector clearing of each page, we can reprogram the chip. And at one instant, all the sectors of memories are not erased. One by one, sector by sector, the memory is erased. Okay. Now next is types of RAM. What is RAM? Before jumping directly to the types of RAM, I would just give the idea what RAM is. RAM means random access memory. It is the working memory of a processor or a controller used to store the data, which is or any other information which is essential while execution of the code. And this RAM is a volatile memory, meaning that its contents are lost after the power loss. Suppose you store a content in the RAM and switch off the power, all the contents of RAM will be destroyed. Okay, so RAM is a volatile memory or a working memory of a processor or a controller, and as the name suggests, random access memory. You can randomly access any memory location from the locations. Okay, you don't need to traverse each and every location to reach your desired memory location, as opposed to sequential access RAM. In sequential access RAM, if you want to reach a particular memory location, you have to traverse through each and every memory location, and then you reach the particular memory location. Okay, so now we will see the types of RAM. Okay, first is the static RAM, SRAM. Second is the dynamic RAM, DRAM. Third is the MVRAM. Okay, now first the diagram on the right side is the implementation of SRAM, and this is the implementation of DRAM, just below it. Now first we will see the cell implementation of SRAM. Static RAM consists of total six flip-flops. Sorry, six MOSFETs. Okay, the first four MOSFETs are in the middle, and fifth and sixth MOSFET are used to control the reading and writing part. Okay. Now you can see the first four MOSFET, these two MOSFETs. You can compare this middle part, which forms the flip-flop or latch, with the cross-coupled inverters. Okay, means two inverters which are cross-coupled in opposite direction. Okay, and they are in parallel, connected in parallel. So this part, which is a latch part, middle part, first four flip-flops, which is the middle part of this, forms the latch or a flip-flop part. Okay, and see, whenever you want to store a data 1 or 0, it is generally latched in this part or stored in this part. Okay, and every cell has a 6 MOSFETs inside this. This whole diagram is a picture of a single memory cell, and single memory cell of a SRAM has a 6 MOSFETs inside it. Okay, so you can imagine number of cells on a silicon chip. Okay, so you can see if you want to read or write the contents of this SRAM, the reading and writing contents is controlled by this word line. This line, word line, controls reading and writing content. This is connected to these two MOSFETs, which in turn control the bit lines B bar and B. Okay, now suppose if you want to write 1 inside this SRAM cell. So B bar is this signal, B bar is given logic 0, and bit line B is given logic 1, and word line is given logic high. Okay, so the one is latched inside this flip-flop part. Okay, or you can say latch. Okay, now suppose you want to write 0. I want to write 0 inside this memory cell. So the bit line B is given logic low, bit line B bar given logic high, and word line given the logic high. Automatically you can write the logic 1 inside it. Okay, now if you want to read the contents of this memory location, what will be the method? First we apply logic high signal to bit line B, logic high signal to bit line B bar, and logic high signal to word line. Okay, after applying logic high signal to all the three, we can read the contents of this flip-flop. So similarly, reading and writing is controlled by this word line. Okay, so this was the structure of the SRAM or static RAM. Now the problem is this static RAM is having lesser capacity, and it is a very expensive type. But the access time is very less, 10 nanosecond access time. That is one advantage. Okay, but we have some other variations in RAM. The next variation is the dynamic RAM. So the dynamic RAM consists of the word line, it consists of the MOSFET, it consists of the capacitor. Now this MOSFET acts as a gate for incoming and the outgoing signal, and the information inside the dynamic RAM is stored in the form of a charge. Now this is the dynamic RAM cell representation. Okay. Now, what is the problem when the information is getting stored in the dynamic RAM or DRAM in the form of charge? There is a possibility of the information gets leaked out. To avoid this situation, we have DRAM controller. These are the circuits which are used to refresh this dynamic RAM. Okay, DRAM controllers are used to refresh this dynamic RAM. Okay, so because of this refresh requirements, its speed gets reduced. Speed of dynamic RAM is less than the static RAM. It is generally 60 nanoseconds. Okay, and the cost is less. Cost of dynamic RAM is less, but the capacity is high. Okay, so this is the difference between the static RAM and the dynamic RAM. Okay, now next is the non-volatile RAM. Now non-volatile RAM consists of the SRAM and the battery backup. Okay, now you can see that whenever the power supply is given, it works. But in the absence of a power supply, we need a battery backup. So NVRAM consists of the static RAM plus the battery backup. And the example is DS1744 from Maxim Delas is the example of a NVRAM. Okay, fine. So in this way, we have completed the memory part of the processor and controller. Thank you for watching.